All right, now, so after looking at the transition metals, now what we need to take a look at is polyatomic ions. This is a little bit different. It's different than what we're looking at up here than a monatomic ion. Polyatomic, just as the name implies, more than one atom making up only one ion. Okay, so what we're looking at here is there's more than one atom in the whole one ion. It's a polyatomic ion, okay? So it's a little bit different than just the I that we're seeing. All right, the example that we can take a look at is this. NO3, which has a minus charge. The whole thing, the whole NO3 thing is its own ion. It's not a nitrogen and an oxygen getting together and balancing a charge. It's the NO3 getting together and forming its own ion, and its ion has a 1 minus charge. Now realistically, all you do with polyatomic ions is the exact same thing that you do with regular naming, with monatomic ions. You take a look at what it's with. So let's say that we had lithium with this NO3 with a minus. Lithium has a 1 plus charge. Let me get that. Lithium has a 1 plus charge, and that NO3 has a 1 minus. So just like any other ionic compound, we're going to balance them. 1 plus, 1 minus. Well, you only need one of each. So Li gets together with NO3 this way. That NO3 needs to stay together. You keep it all together. It's got its own name. We'll take a look at the names in just a second, but I want you to realize that all you're doing is balancing the charges just like you are if it's a monatomic. Okay, let me show you that NO3 thing again. Let's say we have magnesium now, which is a 2 plus with that NO3 with a 1 minus. Now again, we've got our 2 plus and our 1 minus. The least common multiple is 2. So we need, whoops, the least common multiple is 2. So we need only 1 magnesium, and yet we need 2 of these NO3s together. You gotta keep that whole NO3 together. So we only need the 1 magnesium. There we are. Then we have our NO3. Keep it together. It's its own polyatomic ion. Keep it together. But we need 2 of them. Well, if we need 2 of them, see, in essence we have the 2 NO3s to balance off that Mg, which is a 2 plus. How do we describe that? Well, we put parentheses around the NO3 and we say we have 2 of them. So NO3, we need them to stay together, and we have 2 of them. So this right here would be how we balance the Mg with a 2 plus and the NO3 with a 1 minus. That's a polyatomic ion thing. Okay, now how do we name them? Well, we need to know the names of the polyatomic ions. There are quite a few of them. I'm only going to ask you to learn seven of them. And you do really need to know them from now and through the rest of the year. I'm only going to give you 1 positive polyatomic ion. I'm going to give you more 1 minus ones. I'm going to give you a couple 2 minus ones and only 1 3 minus ones. So this is a nice little chart to take a look at. We've got NH4. Again, the whole thing, NH4, stays together, and this thing is called ammonium. So if you see ammonium as a name of something, you're not going to find ammonium on the periodic table. Ammonium is the NH4 polyatomic ion. Okay? We have 3 polyatomic ions for the negative one. We have hydroxide. That's an O and an H together with a -1 charge, hydroxide. We have that NO3 one that I just showed you, which is nitrate. And we have C2H3O2, and its name, I'm running out of room here, is acetate. Acetate. So C2H3O2 with a minus charge is the acetate ion. There are 2 2 minus ones I'm going to give you. SO4 with a 2 minus, and that is sulfate, sulfate, SO4 2 minus. And the other one is CO3 carbonate, carbonate, okay? And then lastly, the only 3 minus one is going to be the phosphate ion, okay? Now notice, these are the only 7 I want you to learn. You do need to know them. Notice that they almost all have 8, okay? Nitrate, acetate, phosphate, etc., etc. We have the hydroxide. That's one of the only ones that ends in "ide." Obviously, the other ones that end in "ide" are going to be monatomic. So notice the difference between phosphate and phosphide. Phosphate is the polyatomic. Phosphide would be just the P, okay? So polyatomic ion, that PO4 stays all together. Sulfate, carbonate, hydroxide, nitrate, acetate, and then ammonium. All right? Again, naming these things is really as simple as remembering your formulas for things. You're gonna have to know those formulas and the names. If I say name this thing, where I put Ca2, nope, I don't want that, can't have that. So Ca3PO42. The name of that thing, not tricalcium, no, just straight calcium, because we're still talking about a binary ionic compound. The cation is always named first, and its name is the same as the element name, calcium, okay? It just happens to have a polyatomic ion with it, and so it is the phosphate ion, so calcium phosphate, okay? Now obviously if I had given you the name and asked for the formula, what you would have needed to do is take a look at calcium, what its charge is. It's a 2+. Phosphate is a PO4 3 minus. We've got our 2, our 3, our least common is 6. We need 3 calciums, we need 2 phosphoruses, and isn't that exactly what we have up on top? We have the 3 and 2 respectively. So there's your polyatomic ions and how to put those together.